So here's the deal. Here's where we're at right now. I'm going to leave the homework up for just a second. We're at 521. Why are you both teacher notes? Where we talk about perfect square equations. 522 is like a pretty important lesson, and I don't really want to do it with only half of you here. So yeah, I hate this, but we'll probably just do something else tomorrow since more than 50% of the class is gone. It would just be like bad of me to try to make that happen. So 522 homework will probably get shifted to next week as well. You guys are killing me. This is not good for my planning. Steven, are you in band? No, you're orchestra, aren't you?
Steven's art. Yeah, Steven's one of those. I'm one of those kids.
My sister was an art person.
I mean, we have nothing against art. We just have things against not being in band.
All right, now.
So what?
What? Oh, because they just aren't shoved back in there correctly. I'm not really helping with it. I'll fix that in a moment. All right. Let's have a hot tub party.
Oh, stop. Yeah.
I'm down with that.
But what if it's really a time machine, and then we can go back in time, or forward in time to when your homework's already done?
Now that'd be great.
That's a good idea.
Maybe forward in
All right,
time.
so
You go forward in time,
yeah.
then you wouldn't be there to do your homework, so it wouldn't be done.
But would you?
You would not.
Unless you went back in time again.
But you don't know yet if you did go forward and then back again to then go do the thing.
So you might just have your homework.
This is when the space-time continuum
May
is
or
broken.
may not.
Depending on how responsible and determined you are, you might have it.
All right. So today we're changing gears a little bit. Quadratic equations literally mean equations that zero out, like equal zero, right? Those trinomials that, like, for when we talk about quadratics, we put them in the form of equal zero, right? So we have everything on one side. Today, we're not going to be like that for the specific intention of having perfect square equations. And this is why I can't continue to move on tomorrow. I might try to teach a little bit of that today so that you get an intro to it and then pick it up on Monday. I appreciate that you're vampiring, but dude, that sounds bad. Like, I appreciate that you're covering your cough, but that sounds bad.
Jacob,
you just spit something out or whatever, I get it. I cough so bad.
Oh my god!
This video right here is a prime example of why middle school teachers get sick.
Then you
Put your book away and get out graph papers. So.
gotta stop.
And everyone who's getting
Yeah, see what you guys just did? You just made Miss Collins and shut her wall.
Yay. Sorry.
so maybe their wallet every day though.
Alright, so we're going to help Ernie with his hot tub installation.
Yeah.
Now, he hasn't yet decided how big of a hot tub to buy. So we're going to say it's X in size, like X length. But he does know how much space he has to work with, right? So he's got his patio space. So Ernie decides he's going to add a 3-foot wide deck on 2 adjacent sides of the hot tub. If Ernie's backyard space, which is also square, is 169 square feet of space, what's the largest hot tub he could order? So let's think this through. Draw a diagram just draw a square on your paper, and if you want to make it nice, draw it 13 by 13. But you don't have to, but that would be 169 squares. So that's 169 feet squared. Now, his hot tub, we're trying to get guided to that, will be X by X. And then he's going to add on a 3-foot deck over there, and add on a 3-foot deck over there. And in total, it's 169 square feet.
Wait, so if we have a, as your 13 by 13.
So 3 foot deck, you could go ahead and you know where 3 foot is. Now we won't always draw things like this out, right? That would be a little excessive.
I'm just wondering, like, so it's not supposed to look like a rectangle.
No.
Yes, it's a square, and squares are rectangles.
It's
Oh.
not supposed to look odd. So
It should be a square.
Okay.
His backyard is square. They told us it's square.
Make sure that you found that.
I can't draw perfect squares. Forgive me.
I can.
No one.
Yeah, because you're on graph paper. All right, now as we utilize our graph paper to see, if we know it's a 3 foot deck and we know that there's 169 square feet total, we can figure out that if I got 3 and 3, that this section here would be a square of size 100, which has is 10. But let's not go that route, right? Let's go the algebraic route. So what I actually have in this space is what area, don't give me 169, what area is actually in this space?
69. Would it be, wait.
We don't
that
know
base
what
square
x,
3x and
9.
x squared, 3x, 3x, and 9. Right, what we really have is x plus 3 squared. Write that down. X plus 3 squared.
They hate this.
No, you don't.
Very model.
You secretly love it.
That's a lie.
Shh. Your lie is a lie. No, you.
Oh, sorry.
That's the one
Too much.
time I'm gonna. I was waiting for
Talking
where that
too
would
much.
be convenient. All right, now if you think back to integrated 1, and I don't know how close to the book Mr. Hall stayed. There was this method called looking inside. You guys remember what I'm talking about?
Oh.
Maybe I don't know.
So this method of looking inside, we already did that with this problem without even like really thinking about it. We knew that if we have a square space, something square, that equals a perfect square value, what we actually know is x plus 3 equals 13. Right? Which then we know x is 10. That's an I don't need the quadratic. I don't need any of that nonsense. I can just solve it with pure algebra and get rid of the square by saying, I know what this is squared. Now, really, there would be a step in between that we could say this is 13 squared, and then we could square root both sides. But we're already good at this. Right? Now, not all of these values are going to work out to such nice numbers. Like, pretty much none of them after this. So not saying absolutely none of them, but like, what's the point of a super easy problem if it's not going to, like,
The rare
we got to push you to get better at this. So, we know that the biggest hot tub Ernie could install is 10 feet by 10 feet. Take that knowledge and help Gabby. I shouldn't need to read it for you. We're going to help Gabby figure out the size of her rock garden, and from there, we'd be able to help her know how much rock to buy. But here's your situation with Gabby. I'm going to highlight some important stuff, but dive into it. Try this on your own for a minute.
Can I? I sure hope you can.
What?
Because I'm confused about something about this. And I feel
For
like it'd be
Gabby
easier-
or for what?
For Gabby, because I feel like it would be easier to explain.
Do it on your paper first. Once you can show it to me on your paper, then I'll let you come up here.
It's just 6 inches square. What?
Is it still 169 feet?
No, this is totally different, guys.
Well, what's the square foot of her?
12. She's creating a rock garden that is 12
Is the
square
frame,
feet.
is if this is like this square here is like the middle one, is the frame going into or out?
The frame's on the outer edge. So if you were to like look at a picture of this, you'd have rock garden, rocks, right? Frame.
And then the area inside the frame is the 12 square feet, right?
Yeah, the area of the whole thing.
Wait, so it's not a corner?
Including the frame?
Read this. Read the problem. Stop asking me questions when you're 3 words in.
Like, so it'll be like, shouldn't it just be 12? So it'll just be like this?
How could it be
The
12?
garden and the frame will cover 12 square feet.
Wait, will it be like this? Or
The garden
Okay, I got it.
and the frame will cover 12 square feet, not a 12 by 12, not a 12 by 12, 12 square feet.
So it'd be like 3, 4.
No, because it's not.
Oh, I need so I need the square root of 12.
Just be 11 then.
No.
No.
Earth it. Do we need the square root of 12?
Satya, just work on your own for a moment. You are so hung up on let me just shout out whatever questions I have. You never give your brain time to process. Draw out a picture, which I'm about to do to help you out, but I can't answer 6 questions at the same time as giving you time to think. I'm not answering questions right now. Sorry, I'll just be that definitive. I know that sounds like a jerk statement, but I want you guys to engage with this on your own. Mm-hmm. Now, if I want to make this easier, I could either cut at every corner and square out 6 inch, like 36 square inches, 36. That's annoying though. And this is feet, and that's in inches, and that's annoying. Can you tell me what I could do visually to make my life a whole lot easier? Maybe? Nah, we could. Sure. Yeah, we could.
No, wait, you could pull the square root of 12 and get that small and then you intercept from that with foot, so you pull it.
Make it the same thing it was with like Ernie's hot dog. Just take it.
What would this face be now?
1 foot.
1 foot. So if I shift what my model is, now I haven't changed anything, right? I just shifted so I can look at it more easily. This now will be a foot, and this will be a foot. So if I talk about the dimensions of my square, what's the edge length of my square measure? Thomas?
It's X plus 1.
Yeah. I'm going to say R plus 1 just because we're working with rocks, but it's this unknown space and 1 foot. So we have R plus 1 in a square equals 12. I just made it the rock length, like the size of the rock square. You could use X. It wouldn't make a difference.
Using 9 and 2 instead of R.
Wait, so let's look inside. You guys do R plus 1 equals the square root of 12.
Yeah. So if we look inside,
It's a big
we can
number.
say R plus 1. Sorry, I should have started lowercase to begin with.
That's not a big number.
It's a small number. A complex.
Wait, what? Oh, you mean
What's the square root of 12?
that's
3.
3 point something.
3.464.
So then that leaves me with R.
2.46 something.
That's not the area though.
That's the length of the rock garden.
So it'll be 2.46.
That's not that big. That's like a rock garden.
But then,
Yeah, you're right.
You don't need a big rock garden. Do you want a
now wait, hold on. What if I come back up here and I take it a quadratic route of saying R squared plus 2R plus 1 equals 12? right? If I factor that out, or not factor, but multiply it out. And then I could say r squared plus 2r equals 11.
Do you take the, wait, what do you do then? Then what do you
I'm just hypothesizing things we could do.
No, then what do you do?
Well,
I don't know. I'm just doing algebra.
whoa.
We want to play everything.
Like, all I've done is apply some algebra. I haven't really solved it. I'm just saying we could also do. But from here,
I think it's the two. What do you
outer,
mean?
inner, perfect square.
Oh.
Perfect square trinomial. Yeah, outer, inner. The 1r and the 1r. So I really, and this is killing me now, so I'm going to just change it. This should be a small r. And the reason for that is just what we use uppercase versus lowercase for, which is not a huge deal right now, but it will become a bigger deal as you get higher up in math. So this doesn't really work nice, but if I do r squared plus 2r minus 11,
Then it becomes.
I can get quadratic.
Those same things.
Right, and then if I factor and I solve, I'd still get r equals 2.46. I think the look inside method was easier.
So that's how you do
Taking
solve.
this off.
That's how you solve a quadratic.
That's the quadratic way to get there. Because I make it equal to 0, and then I can graph it, and I can see what are my x values. One of them is going to make sense, if not both of them. But the one that would make sense here would be 2.46. If you want to try this, grab a graphing utility, a calculator, or Desmos, and we could plug this in, r squared plus 2r minus 11. This would be one of our answers.
What does Desmos mean?
I have no idea. A word,
Look it up.
it's the name of their company. It's probably an acronym.
Huh.
So then if we want to find the area of the garden, we just square that.
6.0518.
So
So 6.
6. Or 6.1.
6.
I mean, if we rest around, it would be 6.1. Does that make sense? So we got two different methods, and actually probably more than that if we get real. We got at least two different methods to solve this. Okay. Question? Oh, I thought you had a hand there. So, look at 560 and check out ABC and see what you find from solving all three of those. We have three different cases there. I'm going to drag this back onto the main screen. Work for a minute on your own before we talk with anybody. Yeah, that normally lives at my desk.
Wait, what?
Oh, the panel's gone out.
What is that?
Calculator that doesn't have a solar panel
Oh, I thought that
anymore.
was so like. I thought that was like.
That used to live at my desk, and I had tape over it. And then apparently somebody got curious, and they decided to destroy school property.
Wait, why would taking a tape off destroy it?
They took out the solar panel. Like literally, the solar panel's gone. The thing that is under this is a solar panel.
So it's not battery. Like,
They have
so
batteries
this
in
is a
them, but
solar
that
panel?
charges batteries. Yeah.
This?
You cover that up long enough.
Did
you
you
charge
not
it.
know this? Well, you never. Why do you like charge your calculator?
I put clear tape to keep the panel in there.
Oh.
A plastic piece holding it. Can you do your math, please?
I'm Oh, there's a D to it. Oh, there is a D.
It's just the one
Yeah.
person at the table with the book in front of him.
Now I'm done.
This is yours.
Now it's
I think somebody said that word. I wonder what it's.
we shouldn't really need to diagram these.
I put yeah.
Now, A would be weird to diagram because we'd have X take a. Should I just like let you guys work and do your own thing? Like, you obviously don't need me. Your socks are more important than what we have to say here. Do you even have ABC written down on your paper?
Yeah.
Do you have D?
Yeah.
Did you move on forward?
No.
Do you know how to do these things?
Well,
Have you in the past frantically come to my classroom telling me you don't know what to do with things?
Yeah.
Do you think you might want to listen to me? Otherwise, like, I can leave. I don't need to be here. I could honestly go get a job as an actuary and make 3 times what I make as a teacher. And you're sitting here as an 8th grade student talking about your socks while I'm trying to teach you about quadratic perfect square equations. If you don't want to be in my classroom, leave. Because I don't need you in here if you don't want to learn. I'm 100% fine with this being documented right now. So if this keeps happening, I'm just going to email this to your parents. Say, this is what I see from Satya in school. Either turn it on and engage as a student, or leave. And go sit in the office and talk about your socks with the secretary. If we try to diagram A, we could. It would just be really weird because we'd end up with negative x values involved. Because if we do x squared, right, a square of x, but then we'd have -1, or we like come in by, like we take 1 away from the x, then we'd have a -1 value out here, like we think physically about the algebra tiles that we've used before. And then this area up here would be positive, because a negative times a negative would make it positive. I could make this a perfect square using positive and negative tiles, and then there's some like counteracting that happens, right? The x will get squared, and then these negative x's will take away, and then whatever this value comes out to be, which I think is +1, I don't need to do any of that. What can I do if I look inside this equation?
Just equal 1.
No.
What?
Steven,
X would equal 3.
how?
You take the square root of both sides. I mean, that's what I did.
What squared will equal 4?
If I were to do a B, sorry. Yeah. Oh.
So what squared equals 4?
2.
2. So if I need that to be 2, x must be 3. Or -1, which doesn't make sense in like real physical terms. Because -2 squared makes +4. So we could get x equals 3 as physical real, or -1 if we don't care about real like lengths or things like that. B, we got to ask ourselves, what squared equals 0? 0. So if 0 squared, well then how do I make this 0? As Chris already said, we make x 1. Is there another solution?
No. Its vertex is on the...
So its vertex is its 0. Right, so this would only touch the x-axis once. It would not go through the x-axis if that's our only solution. And then C, who can talk through C? Satya, can you explain it to me?
So when you look inside, you gotta see what squared will equal -4.
Okay.
And there's a problem with that,
Why?
because if you square a negative number, you're going to get a positive number. If you square a positive number, you're going to get a positive number.
So what's my answer for C then?
No. I saw this somewhere. I think it's like something
No.
I don't know. It is not possible.
I know what it is.
Thomas?
It's a circle with the cross through it. No solution. No real numbers.
No solution. Now, be careful, because you're mixing 2 different things. ARN is what we use for all real numbers when it's that solution. No solution is this,
Yeah.
which that represents the empty set, which just means nothing that we have yet will work here.
So what's the
So
I?
no, so we're not
I
there
like
yet.
imaginary numbers.
Why are you talking about I?
Because
Have we talked about I?
No.
No. I'm going to stop over teaching this class because I think you guys get your brain too wrapped up on too many things.
Stop.
You'll get 4.
So really, we could use look inside for both of those. We could try to use a quadratic. So wait, with C, if I try to multiply that out and move the 4 over, all we really see is a parabola that's been shifted up, off, and it just never crosses the x-axis. Right? That doesn't mean it's not a parabola or anything like that. It just means it has no x solutions, so it never crosses the x-axis.
Would it be possible to get a graph that has no y or x solutions?
Depending on what kind of graph you're talking about. We can graph a circle.
Well, yeah,
that
but
doesn't
like
cross the actual
that's
y-axis.
parallel.
No, that will go on forever.
It goes like
Eventually.
Forever.
But like no, remember this we had a problem where if you half your distance each step you take, you're never gonna reach there.
That's exponential.
Yeah, but could you apply that
No,
to
but
how?
that's not quadratic.
No, so what I mean is, I know like as farther out you go, the more intense the slope gets. Is there a point like? Are you ever gonna actually reach that x-axis if you put it far away?
Well, I'm not saying we will cross the x-axis. I'm saying we have to cross the y at some point.
No,
We have a sideways.
That's x equals parabola.
Yeah.
Yeah, and then you
And then I'll
wouldn't
always-
necessarily have to cross the y, but you will cross the x at some point. So we look at the expression x minus 3 squared equals 12. Now I dislike how CPM does this. Shaded is positive, open is negative. And I get why they're doing it. So if you like order a pizza and they show up and you open the box and it's empty, they owe you a pizza, right? So empty spaces are like debt. That's why they use them for their negatives. So like it's taking my brain some time to transition through this, but shaded is positive, empty is negative. Right? So if we think about this as a perfect square, x minus 3, we end up with x squared minus 6x plus 9. Like 9, be careful. So,
You can also write that.
what's a solution? So, try this. Take a moment. Engage with it. Solve for x, yeah. In radical form. So we're not going to decimal form. In radical form.
Wait. Are you asking for the zeros? Or?
The x, yeah. What solves this? So right now, it's not technically zeros. It's solution points because we're not zeroed out. Right? This is not in quadratic form. It's in perfect square equal to a constant form. Question or answer?
it doesn't.
Oh, it totally does work.
Oh, wait,
Yeah, it
no,
works.
yes,
It works.
no.
So essentially what we're asking, guys, is what dimension of x will make this whole area 12? Which, as long as my negative spaces aren't bigger than my well, I already have 9. With like I already have 9. But these are going to take away from it. How do
So
I?
you are asking for zeros.
Not, I mean, it depends how you decide to solve it. The zeros only matter when we have something equal to 0. We don't here. Does that make sense? That's why we aren't calling the zeros. If you move it over and you make it x minus 3 squared minus 12 equals 0, then you'd be looking for zeros. Richmond.
It should be x equals the square root of 12 plus 3. Right?
Yes.
I want to show why. So I don't know if this is really clicking.
No, that was actually all
Radical.
Yeah.
Oh, I was thinking of, I was thinking integer.
That's-
I'm very confused because there's no integer.
That would be exact.
No, radical form is what we're asking for. So x minus 3 squared, right? Here's your parabola. We are not looking for the zeros because right now there's only one. It touches the x-axis once.
Yeah.
But we're looking for where it crosses, literally at what value of x is. So instead of the x-axis being my point that I cross, I have this other kind of like new axis that I create that takes the place. Now, alternatively, if I make my quadratic x minus 3 squared minus 12, right? Shift that 12 over. The zeros, quote unquote, are the same thing. So this is the dangerous part about me answering your question, Satya, of like, we're not looking for zeros when I deal with this specific function because it's not equal to 0. We're looking for the 12s, quote unquote. Like, where does the function equal 12? And if we solve it algebraically, as I think most of us process through, because we're asking for radical form, we'll square root everything to begin with. X minus 3 equals radical 12, and then x equals radical 12 plus 3. Now, normally, for what it's worth, in math, write the constant first. So the one, well, and they're both constants, but write the integer first. So we would say 3 plus radical 12. And here's the issue. There's not just one answer. Right? As we saw from Desmos, there's two. How do we, from the algebraic form, get both answers? Yeah, you do. You just forgot it. You've done this before. Satya?
Okay, I have an idea. I don't. So, maybe it has something to do. I think it might have something to do with absolute values. I don't know.
It does. That was from your homework last night, right?
Yeah.
The absolute value functions. What's the square root of 4?
2. Yeah, that was it.
Plus or minus.
Oh, yeah.
This is my favorite math symbol. Well, okay, that's a big statement. It might not be my favorite math symbol, but guys, instead of writing out 3 plus radical 12 and 3 minus radical 12, we can just write out 3 plus or negative radical 12 because this actually has two answers. It has a positive answer and it has a negative answer. And since we're not dealing with it as decimals, we just write plus or minus. So please make sure you have that on your paper, that symbol. That is a huge time saver.
We used that symbol last year.
Because you could say square root of 4 is plus or minus too.
We learned about it and we used it.
Because we could say things like this, like that. That's true. That is an application of that symbol. So then, if we want to go to decimal form, this is where things get dangerous. We got to figure out what radical 12 is in decimal form and add 3. And this is where people screw it up, we don't find radical 12 and subtract 3. We subtract radical 12 from 3. So then, our two answers that we get would be the negative 464 hundredths and the positive 6 and 464 hundredths. So I would make sure that we have those on our paper just for making it clear that we, and that, so this is the thing that gets screwy. This is the right way to write it according to mathematicians, but when we go to do the math and get it to decimal form, it's easier to do it that way.
3 square root of 12 and then square root of 12 minus, no, 3, no, square.
Yes.
Square root of 12 minus.
Yes. Questions?
So why don't you flip this?
What do you mean?
Never mind.
So if we're writing in radical form, not going to decimal, this is the appropriate way because it's easier to say since you don't say the radical until here. If I leave it the other form that we had first, radical 12 plus 3, was that radical 12 plus 3? Or is it radical 12 plus 3? So like how we say it gets screwy. Saying 3 plus or minus radical 12 is very clear. I have 3 plus or minus radical 12. That's why we write it in that order with the integer first. Or just whatever's not radical first. Honestly, it doesn't even have to be an integer. Questions on what we did here? Just pure forcing the algebra to work. So check out these. You don't even have to solve them. What I want to know is how many solutions there could be. Then, once you process through all that, try to solve them all. Now, if you can't figure out like a prediction for how many solutions, go ahead and try to solve. The first thing I want you to do is just look at it and see if you could guess how many solutions would there be. You don't even have to write this down anywhere, but then we'll solve it. So take a moment, try to determine how many, and then solve it. And you can talk with each other if you want to work out any like, wait, I think this or this might be true.
I think it's 5 or negative.
Wait, there's
Or
5 solutions?
No, 5 as one of the solutions. Or negative.
Yeah. So you just gotta get to make -7 or 7. Wait. Yeah, 5 negative. So 5 B. For B, you just gotta make it square root.
Oh wait.
Negative.
Is that even
Impossible.
possible? So no.
So none.
So wait, it's like no.
It's like the little
solutions.
circle with line.
No, we don't. Radical form.
No solutions.
Oh. Yeah. C, you just gotta get. You gotta get it to equal.
Just 2 squares.
Let me just use glass.
I think I got it. For all of them? Like the answers? Or.
No, just
So-
P.
Oh, yeah.
Radical.
For A, it's 2. For B, it's none. For C, yeah, G is 1. D is 1. E is none. And F is.
So what is
Like
this?
we're learning.
Or it's solved.
But
It's
if
solved.
this says no solution,
4
how do you have one solution?
Why?
And
Because
then
you gotta get
it's
that to equal
zero.
0. And you can't because it's plus 11.
Yeah, X should be
So
0.
when
That's
X
like
is
one
zero
answer choice.
I was thinking of
Because you're adding 5.
Yeah, like
Yeah,
one
exactly.
answer.
Yeah.
No,
So
I
you
see-
gotta
I know
get
what
the
you
other
mean.
one to equal
So
0.
can-
And you can't get X plus 11 to equal 0.
So I have to be
Radical
negative
one
11.
half.
No. Oh yeah, it could be negative 11.
Then
I was hoping
It
you would
can't
get
be
there on
negative
your thank
0.5
you.
because then we would be
What
adding
is
5
negative
and
11?
it would be 25. So it's just
Ugh.
Then square root of 20.
Wait, what? That's negative.
You said negative 1 e.
No, I said negative 20.
It sounded like negative 1 e.
20.
Have we talked about simplifying radicals?
No.
Since you guys are talking about
I think
radical
so.
20. Because radical 20 can be simplified.
2 squared
Can
is
you just say radical 20?
So let's review simplifying radicals really quick because I only have 5 minutes left. If here we're going to take an algebraic method and square root both sides first because this is not a perfect square, radical 20 has a perfect square in it. I could rewrite it as radical 4 times 5 because 4 times 5 is 20. Just algebra, right? Rewriting. So it turns into 2 radical 5 in simplified radical 4.
Wait, what?
Because I can then make this square root 4, square root 5, all still just applying algebraic rules.
Oh.
This is the same as this.
Square root of 4 is 2.
And the square root of 4 is 2. Square root of 5 I can't deal with. But square root of 4 I can. So the simplified radical form of radical 20 is 2 radical 5.
So,
But again, hang on, it's positive or negative. Okay, sorry, what's your question?
is there a way to find out what the unsimplified form is?
It's just the original. So like radical 20 is the unsimplified. So like radical 36 or like radical 49 over here
That's
has a perfect square root value
But radical 50.
and or the negative. But radical 20 doesn't. However, it has part of it that has a perfect square root value. So imagine we were dealing with something like, I don't know, 40.
So what if you did 10?
So radical 40, I can think of 4 times 10, right?
Oh, it'd be
So
four
square root of,
So
Negative
2
4
squared.
times
2 radical 10.
because the square root of 4 comes out. If I push it back in, it becomes 4. 4 times 10 is 4. So this would be plus or minus 2 radical 10. So we'll continue to do more with that this year. But what are our solutions for A? Just shout them out.
5 and negative 2. Yep.
Oh yeah, sorry. I was thinking we need to make 10. 5 and -2 to make that 10 and or make it -4. Thomas, what about B?
B, no solutions.
Why is that?
Because it equals negative.
It is a negative number. What about C? We were just discussing this, but what else do I need to do with that 2 radical 5? Thomas, go ahead.
Plus or minus 1.
Ooh, careful. Not plus or minus 4. It's 4 plus or like -4 plus or 2 radical 5. Need to leave space for my 2. Sorry, I was trying to cover up that dot. If this needs to become 0, x equals a half. Is there anything else? I think that only has one solution because it's
When it equals 0,
so E
no solution.
F.
None. I mean, 1.
Negative 11.
So what pattern could we identify here with perfect square equations? Chris, give me one part of it. Jacob, give me one part of it. Chris pops along.
It's a whole number. It's a whole number. It'll have
zero,
two.
then
If
it
the
will
answer is
be
a whole
solution.
number, it will have two.
You're giving 2 different pieces, and I like it. Just don't do it at the same time. You're saying if it's a whole number,
Yeah.
what?
It'll have two different
It has 2 solutions. You're saying if it's 0,
You only have one.
and if it's negative,
It'll have none.
it has none. So, why does this only have 1?
Because if you subtract
Because
5
it
from
did,
both sides and 0.
It's equal to 0.
It's not in perfect square form.
I don't
Right.
know why.
So, here's the... I got 2 minutes. Here's the connection that we were trying to make today. If in perfect square form, the answer, like 0, positive, or negative, tells us how many solutions. So if we step down to 63, I don't need you guys to write it out, but we're going to talk about it real quick. My smart board.
It's playing with you. That's right.
So think about these for a moment. No, because I'll lose my screen again. What is A going to end up being? No solution because it's negative, right? It would actually be -6.
I think it
I didn't see this.
What would B be?
1.
One solution, right? Which actually we could figure out would be -2. What about C? 2 solutions.
Oh, they tried to trick me.
And then we step forward to 64, and this might be where we need to pick up. Actually, it is where we're going to need to pick up on Monday/tomorrow. Talking about when it's in white.
Positive or negative Monday.
So, have a great time on your band trip. If you're gone on that, if you're not, I'll see you tomorrow.
Which I will.